So I had a customer call about one of these, and they said that their alarm was going off, and then it stopped going off, and some smoke came out of the box. So I went over there and I poked around a little bit, and what I had found was a burnt up capacitor inside here on the circuit board. So I went back to my shop and I started looking through boxes of spare parts, and I happened to find more of these. I found a few of them, and they all had the same issue. There is a little, see those two wires there? There's supposed to be a capacitor right there. And so I guess I've kind of figured that these are having an issue with burning up that capacitor. Now these are old. So that's a 1991 for that one. And it's just very basic. All it does is send power to an aerator motor and operate a float. That's the only alarm system these had, was just this float. This is what it sounds like. It's nice that you can silence it. Here's what it looks like when it's pulled out of the box. Here's the face of that control panel. So luckily in that situation, I was able to find another circuit board in my spare parts that hadn't been used, and it still had that capacitor intact. So I was able to get the numbers off of it. And what I had found, it was, I ordered some of these. It was a tantalum capacitor. Looks like these. They do have numbers on it, but I probably can't focus on it. But basically this is a 4.7 microfarad capacitor, tantalum. And whether it needs a tantalum capacitor or not, you know, it might be able to use just a regular, one of those cylinder type capacitors. Like, see, here's a later style circuit board. This one's from 1998, and it has all the same components. It's just much larger, and it can operate like a pressure switch too. But basically here's its capacitor, and I guess I'll explain why it has a capacitor too. So the way Clearstream made these for this float circuit, for all the alarm circuits, it stepped down the power to 12 volts. That's what this does. So you had your alternating current, your 125 volt or 115 volt, you know, it's like a range, but that comes in here and it bridges right to the aerator. That's what these three are for. That would be your output to your aerator. And this one here is your float circuit. So the way these operated, it took power from your 120 volts and it went through a transformer, and then it went through a rectifier to convert it to DC. So the transformer steps it down to 12 volts AC, and then it comes out of the transformer, goes through a rectifier. The rectifier has diodes in it. What diodes do is they prevent electricity from going backwards. So we've probably all seen the animations of alternating current versus direct current. Alternating current, it alternates at a rate of 60 times per second, which would be 60 hertz. And that's, in America, that's how, or United States to be more specific, that's how our power system operates, at 60 hertz, 60 cycles per second. So it's bouncing back and forth. But then, you know, direct current, you've probably seen that animation where it's, you know, pluses and minuses just going around. That's how that works. So the rectifier takes the alternating current and puts it out. It only allows it to go one direction, so it stops alternating. Well, after it goes to the rectifier, it still has some properties of the alternating current, like the pulsation. So after the rectifier, the capacitor, what that does is it absorbs those pulsations and turns it into more clean DC current, where it doesn't have any cycles left in it. So that's kind of how that works. And then this right here is a relay that also runs on 12 volts, and the only thing that does is it operates your light for the alarm and the silence switch. That's all that is. You know, it's like, it tells it if it loses power through your float to turn the light on and switch on. And then this right here is a coil, that one actually operates on 120 volts, and what it does this is the alarm buzzer, and when it activates it operates like an electromagnet. It pulls this plate down really quickly, and that's what makes the buzzing sound. So that's basically how it works. And so these also operate differently than most people would be used to. So when this float is down, it's sending DC current through here, through the float, and back. Whereas most of us are used to floats, when they turn up, that's when they send power through. So this operates backwards. I think they probably thought it would be like a safer method. That way you're sending 12 volts out to your float rather than 120 volts like I've always installed. So, and I guess the question you're probably asking, why would you want to repair this really old thing when you can just put in a newer box such as this one that would basically do the same thing? Well, there's a few reasons. So a lot of these got installed, and this wire for the float, they use like doorbell wire, like 24 gauge wire, single strand, and you can't very well run 120 volts through a single strand wire. Plus you would also have to change this to a different style float. So that'd be one reason why. There's probably a few more. I mean, price too. Like if you were to switch to this, then you might have to replace your alarm wire, that one going out to the float, plus your float, and it would end up being very costly. This box here is like, I think this one's like $220, and Clearstream actually has an equivalent one, but I haven't ever bought it, so it might be the same deal. They might have got rid of this 12 volt circuit where you couldn't even use it. So I think it's a good idea just to try to repair these. So that's what we're going to do. We're going to repair that capacitor, and these will actually run with that capacitor burnt out, but I don't know how long. It might end up degrading this relay or the rectifier. I'm not sure. So if you're servicing these and you see one of these circuit boards, you see the capacitor is all burnt up, you might want to replace it before it does more damage. So let's get to that. You'll need a few things. You'll need a soldering iron, some flux. This is a flux pen. It's pretty easy to work with on a circuit board. You'll need your tantalum capacitor, of course, and this is a solder pump. How this works is it's kind of, you do that and then you heat up the solder in there, and then you hit this button and it creates a suction and you can pull the solder away from your work. So you'll need a few things like these to do this job. Okay, so it's right here. So I need to try to unsolder it first. All that popping and banging, that it's the 3rd of July, so there's a lot of fireworks going on. Alright, let's see if we can get it out now. So here's what's left of the tantalum capacitor. And tantalum is a type of metal. And if I get some of these terms and things wrong, you know what, I'm not an electrical engineer. And electricity is just a theory anyway, so even an electrical engineer doesn't know everything. That's what science is all about. It's all about theories and trying to prove theories. Nothing is fact. It's all just a theory. All right, so our new capacitor, it does have polarity. So I do have an up-close picture of one of these that I'll post, or I'll put it in the video. But you can see a little bitty plus sign in there. So the plus side needs to be on the positive side of the circuit, which I already know that the positive is that side, the far side. But you can't really see it, but on this rectifier, you can see a plus and minus in there. So you would have to, you know, follow your trace to figure out which side was the plus and which was the minus. But I already know that this side's the positive and this side's the negative. So we just need to slide it in through those two holes. And that might be a little bit difficult. Get it in there like that. Bend it over. All right, now we need to solder it. This is actually going a lot quicker than I was expecting. So you want to take your flux pen, get that all cleaned up. It's actually a really easy repair. A little bit of solder on there. I think this is actually rosin core solder, so I probably didn't really need to use all that flux, but it's not going to hurt to get it clean. Make sure everything is bonded well. There we go. That's really all there is to that. Now, if for some reason this still wasn't working or your alarm light was just stuck on, there might be more damage, and all these things are replaceable. So you can, like this relay has numbers on it, you can get numbers and you can get one of those. Same with this rectifier, it has numbers, you can get that. You can even get one of these transformers. It's just a 12-volt transformer, so that's, and it does have a part number on there too. So, you know, if you're messing around with these things, it might be a good idea to take one of these apart and just copy down numbers. But, you know, there also was revisions in these, you know, you do have to be careful with that. But, yeah, so that repair is done. Now let's put it all back together and see if it still works. All right, I've got it powered up right now, so got to be a little bit careful when touching things. But so let's check our AC current first. Looks like I got 123 volts. So let's check our DC voltage. We're going to try that right at that tantalum capacitor. A little bit difficult. Huh. 19.2 volts. That's odd. I was expecting it to be 12 volts. Those tantalum capacitors are rated for 25 volts though, so it might be just fine. I wonder why it's putting out more voltage than it should be. I wonder if that means there was a problem with the transformer. Well, I'm not sure. I'm gonna I'm gonna repair the other circuit board and see what it does. Okay, so I got this board repaired. I believe it's repaired, but I couldn't hook this piece up to it because, so on this board, this little plastic pin set thing here is soldered direct to the board, and this one has pins that pop up and the connector just snapped onto them, so I wasn't able to disconnect that and move it over here, and then I had to add this alligator clip. Don't touch it because it's hot right now with 120 volts. But those first two pins, they take the hot wire, and it comes out and goes through the circuit breaker and back out, and then it puts power into the board. So I had to jump that just to get power to the transformer. But so at that tantalum capacitor, I'm getting 21.3 volts, so it's even higher than the other board. What that means, I don't know. I know that capacitor is made to operate at a max of 25 volts, so maybe it's just fine. Probably is just fine. So maybe there's just variations in the transformers. Maybe they weren't as accurate as they should have been. I think one of these say Archer on it, but some of them I saw, they even, well, not this one, one of them said Radio Shack, so it's not like these are all high-end parts on here. These are a lot of off-the-shelf parts, so who knows. I think it's repaired, but I think this video will at least give people a little bit of insight, to look in those boxes and see if maybe they can repair them. But that's it. A little bit different video, but it was a little bit of fun. The end.